Hello students, welcome to the next lecture on the inverse Laplace transformation. Today I will explain you how you can solve the convolution theorems related problem. I will explain all these 10 problems in a very simple manner. You can simply follow my YouTube channel where you can find the playlist of the mathematics 2, where you can find the last lecture on the convolution theorems and the other lectures. Also you can see the various lectures on the inverse Laplace transformation and the Laplace transformation available at this playlist. So what is the objective is? The objective of this convolution theorem is how you can find the Laplace inverse of the product of the two functions. Make sure this is not equal to the product of the Laplace inverse. You can't write off this manner. Fine. So then how you can find the Laplace inverse of the product of the function? So I can firstly find the Laplace inverse of the first part, Laplace inverse of the second product. I called one is f and second is the g. Then you can write this term in the terms of this integration, and this integration is called as the convolution result, and it is denoted by f star g. Remember, it is not a multiply sign, it is f star g. That means this component I can written as f star g, and this f star g will satisfy these three properties, or you can say like of this manner. So what is the meaning of that? If somebody will ask you find t star 1, make sure it is not equal to t into 1. It is not a multiply sign. So how you can find that? I call this is my f, this is my g, or you can consider this is g or this is f. So I can substitute this value here, that is 0 to t, f of x is x, g of x is my here. So what is the integration of this? It's a x square over 2 from 0 to t. That's the answer of this problem. That's why I'm asking you, this is not the product, this is the convolution here. So for example, I will explain you how you can solve that. Look at this example. They are not asking you to find the Laplace of this. They are not asking you to find the Laplace inverse of this. Fine. So basically they are asking you to find this term. So I can start from the first component, that is I can simply take the 2 part. That means the first component is my f, second is my g. So what is the definition is 0 to t fx g of t minus x into gx. So now if f of t is my 1, f of x will be 1, g of is also 1. So what is the integration of this? It's a small t. Then second component I can take on this as here. This, what is the answer of this component is? I can take on this is my small t star 1. So this is my f, this is my g. So again I can substitute this value here. What is the f of x? X, g of t minus x is 1. So what is the integration of this? It's a x square by 2. That means t square by 2. Similarly, if I start from this 4 operator, I can, what is the answer of this first 3? That is t square over 2 star 1. So what is the answer of this? It's t to 0 fx. Fx is x square over 2 into 1. So what is the answer of this? X cube over 3. So 3 into 6 is here, and so on. Fine. So you can extend them. So you can clearly say I can return this is, it's a 2 1. So I can return this is a 2 minus 1 over 2 minus 1 factorial. It's a 3 1 1 1. So I can return this is 3 minus 1 over 3 minus 1 factorial. Similarly, it is 4 1 4 4 1 1 1. So 4 minus 1 over 4 minus 1 factorial. 3 factorial is 6, and so on. So in general it is n minus 1 over n minus 1 is the required proof of the result. Now look at this, how you can find the Laplace inverse by the convolution result. You all know you can also solve this problem by the partial fraction. Fine, that you can see available at my this part 1, part 2, part 5. But this question asks you to find the Laplace by the convolution. So how you can find the convolution? You can start with this, find the Laplace of the two separate part. This is s minus 2. So the Laplace inverse of this is e raised to power 2t. It is e raised to power 1t. So what is the Laplace inverse of 1 over s minus 1, s minus 2? It is 0 to t fx g of t minus x into dx. Now out of these two functions, you may choose this is f of t, or you may choose this is f of t. That's on totally your choice. If you want to choose this is f, then this becomes my g. If you choose this is my f, then this is my g. That's on your choice. Answer will be the same from the both cases. So if I choose this is my f, what is the f of x? E raised to power 1x. What is the g of t minus x? So it will be e of t minus x. If I open this bracket, 2t minus 2x. Now I have to integrate with respect to x. So e raised to power 2t is my common. So what is the inside is e raised to power minus x. E raised to power 1x and here. So can you integrate them? What is the integration of this? E raised to power minus x over minus 1. So what is the answer of this? E raised to power 2t, e raised to power minus t, e raised to power 0, 1 over minus 1. So if I open this bracket, e raised to power 2t minus e raised to power plus t is my right answer of this problem. Look at this another one. Again, you have to apply the convolution. So I have to break this component into the two parts. Laplace inverse of s plus 1 whole square. So what is the Laplace inverse of this? It's a single t. How you can find the Laplace inverse of this? I can use the shifting first theorem. Fine. So what is the shifting first theorem? Is e raised to power minus 1t Laplace inverse of 1 over s square. So that means it's a t e raised to power minus t. Then you can find the Laplace inverse of this component. You can write here. It is from 0 to t fx g of t minus x into dx. So you can choose any one of the f and any other as a g. So I choose this is my f and this is my g. So it will be x into, replace t to the t minus x. So t minus x e raised to power minus of t plus x. Fine. So e raised to power minus of t is outside. Then it will be my tx minus x square into e raised to power x of dx. Now how you can integrate? You can choose, and this is my first function, this is my second function. You can integrate by parts. Otherwise, as I told you in the earlier lectures, whenever there is a polynomial term, you can write it polynomial separate and here differentiate this until it becomes a 0. This here. Integration of this part until it becomes my here. Fine. Then you can multiply this, multiply this, multiply this with the sign plus, minus, plus. That is the integration of this. This will be tx minus x square e raised to power x minus t minus 2x e raised to power x minus 2 times e raised to power. That's the integration by parts in an easy manner. Now you can substitute this value e raised to power minus of t. When you substitute t, it's a t square minus t square 0. It is t times of this. It is twice of this. When you substitute 0, it's a 0. When you substitute here, it's a minus of t. It's a plus e raised to power 0, 1. It is my here. Now you can open this bracket. It's a t minus 2 plus t e raised to power minus of t plus 2 e raised to power minus t is the right answer. Look at this another one. This function I can return as s square plus a square, s square plus a square. So that means Laplace inverse s over s square plus a square and Laplace of 1 over s square plus a square. So can you tell me what is the answer of this Laplace? Cos of at. What is the Laplace of this? I have to multiply this by a divided by a. So it is 1 over a sine of at. Now you can apply the definition. So 0 to t fx g of t minus x dx. So you can choose this is my f and this is my g. So what is the answer of this? So I can substitute here. It is 0 to t it's a cos of ax and it's a sine of at minus ax. 1 over a is my outside. Now how you can solve them? I have to multiply by 2 divided by 2. What is the formula for that? 2 cos a sine b. It is sine of a plus b minus sine of a minus b. So it is 1 over 2a. What is that? It's a sine of a plus b. So ax will be cancelled out, minus it will be 2ax minus at. Now you have to integrate this with respect to the x, and the first part is free from the x. So what is the integration of this? X into, because this component is my constant, this is my constant, sine integration is the minus cos 2ax minus at divided by 2a from 0 to t. So now you can substitute this value. It is my t times sine of at plus 2at minus at is a cos of at, minus, when you substitute 0 is a 0, when you substitute 0 it is my cos of at upon 2a, because cos of minus at is my plus cos at. Now you can see this will be cancelled out. So the right answer is t sine at over 2a is the right answer. Okay, look at this another one. Find the Laplace inverse of the two components separately. S minus 2 Laplace inverse of s square plus 1. So what is the Laplace inverse of s minus 2? E raised to power 2t. It is my sine of t. So now I can integrate this from f of x g of t minus x into dx. Fine. You have to written here, this is the Laplace inverse of this whole term. Now you can choose any one of the g and any one of the f. Now you can see it's a t minus x. If I choose this is my g, then it will be t minus x. Then you have to open this. So the better is I can choose this is my f of t and this is my g of t, so that my calculation becomes easier. So it will be f is my here is a sine of x e raised to power 2t minus 2x. So e raised to power 2t I can take as a common, then e raised to power minus 2x sine x of dx. Now you can solve this by integration by parts. Otherwise you can simply remember this e raised to power ax sine bx. What is the integration of this? E raised to power ax over a square plus b square. Now since the first term is my sine x, so a sine bx minus b cos bx. That is the formula, you can use it directly. Similarly, if it is e raised to power ax cos bx, you can write it as e raised to power ax over a square plus b square. A, the first term is my cos, plus b sine bx. Fine. Now if you compare them, a will be your minus of 2, b will be your 1. So I can written this is e raised to power 2 into t e raised to power ax over a square plus b square, 4 plus 1 5. A is my minus 2 sin x minus b cos x. Fine, from 0 to t. So now you can substitute this value, e raised to power 2t e raised to power minus of 2t divided by 5 minus 2 sin t minus cos t, minus, if you substitute 0 it's a 1 over 5, cos sin 0 is a 0, cos 0 is a 1, so minus minus plus 5. So now you can open this bracket. I can take 1 over 5 is a common. It is minus of 2 sin t minus cos t plus e raised to power 2t is the right answer of the problem. Okay, look at this another one. Again I can break this s square into the two component. One is the s here and second is this one. Fine. So what is the Laplace inverse of the first part? It is my cos of AT. Second one is cos of BT. Now I can substitute this value here. Fx g of t minus x dx. So I can choose, this is my f. Fine, this is my g. So it is 0 to t cos of ax. This is ax and cos of bt minus bx. How you can solve them? I can multiply by 2 and divide it by 2. So what is the formula for that? 2 cos a cos b. Yes, anybody remember? It's a cos of a plus b plus cos of a minus b. So I can open this bracket. So 1 over 2 integration 0 to t cos a plus b. So ax. So I can take ax, a minus b, x common, a plus b plus cos of a minus b. So a plus bx minus bt into dx. Now you have to integrate this by x with respect to x. So it's a sine of a minus bx plus b into t divided by a minus b plus sine of a plus b minus bt over a plus b from 0 to t. Now you can substitute this value. It's a half. When I substitute t, it's a bt. bt will be cancelled out. So it's only sine at divided by a minus b plus, if I substitute here, again the bx will be bt will be cancelled out. It's a at over a plus b minus, when you substitute 0, this will be 0. So sine bt over a minus b. When substitute here, it's a minus, it's a negative, so minus minus plus sine bt over a plus b. Fine. So what will happen? It's a half. From the first two components, sine at will become common. So it is a 2 sine at over a square minus b square. From this side, sine of bt will be common. It's a minus 2b sine bt over a square minus b square. Now you can take a square minus b square is LCM. So it will be a sine at minus b sine bt over a square minus b square is the right answer of this problem. Okay, look at this another one. Again, you can take, and this is Laplace inverse of 1 over s. Laplace inverse of 1 over s square minus a square. So it will be 1. It will be 1 over a is a negative. So it's a sine hyperbolic at. Now you can start from here. Laplace of this. Laplace inverse of. Make sure you have to return it properly. Find this value you have to return here. Now you can choose either one of the f and either one of the g. If you choose this as a g, then you have to replace as a t minus x. That means sine of at minus ax. Then the integration may take some time. So that's totally on your choice, whether you want to take this or this. So I can solve by the both way. Firstly, I can choose this is my f. So it is a 1. It will be 1 over a sine hyperbolic at minus ax. Fine. So remember, you all know the integration of the sine will be minus cos x, but the integration of this sine hyperbolic x will be plus cos hyperbolic x. Fine. So I can do that. 1 over a is outside. Integration of this is plus cos at minus ax divided by derivative of this minus a from 0 to t. So what is that? It's a 1 over a. When you substitute a, at minus at, cos 0 is my 1 over minus a When you substitute 0, it is my cos hyperbolic at over minus a. I can 1 over a square I can take as a common. Fine. So it's the minus minus plus cos hyperbolic at minus 1 is the right answer of the problem. There is one more way. Instead of them, I can choose this is my f and this is my g. Then what will happen? Then it is a single 1 over a sine hyperbolic ax and g is my 1. You can choose g in such a way that your calculation will be smaller. So 1 over a is outside. Sine hyperbolic integration will be cos hyperbolic ax over a 0 to t. So you can see 1 over a square is outside. Cos hyperbolic at cos 0 will be 1, and you can see both the answers are always same. Fine. So either you can choose this as a f or this as a g. Okay, look at this another one. Again, I can break this component into the two parts, s square plus 4 and 1 over s square plus 4. What is that? It's a cos of 2 into t, and it will be 1 over 2 sine of 2 into t. So I can use this fx g of t minus x into dx. So I can choose any one of the f, any one of the g. So I can choose this is my f and this is my g. So when I substitute g, half will be common. So cos of 2x sine of 2t minus 2x. So how you can solve them? I can multiply by 2 divided by 2, it's a 4. Again I can use as a 2 cos a sine b. So what is the formula for this is sine a plus b minus sine a minus b. So 1 over 4 is outside, 0 to t, it will be sine a plus b. So 2x will be cancelled out here, sine 4x minus 2t. Now you have to integrate this with respect to x, and you can see the first component, this one is my constant. So what is the integration of this? X sine 2t. Sine integration will be the minus cos, so minus 4x minus divided by the derivative of this 4 from 0 to t. So what is the answer of this? When you substitute here, it is a t sine plus 4 minus 2 is a 2 divided by 4. When you substitute 0, it's a 0. When you substitute 0, it's a minus cos of 2t divided by 4. Make sure it's a cos of minus 2t, and we all know cos negative will be the always positive. Now what is the answer of this? It will be cancelled out. So the right answer is t sine 2t divided by 4 is the right answer of the problem. Okay, look at this another one. I have to break this again, e raised to power minus as over s and s of s minus 2. This part is easy. Fine. How you can find the Laplace inverse of the exponential part? That is always the shifting second theorem. Fine. What is the shifting second theorem is? You can find the Laplace inverse of the remaining term apart from the e raised to power minus as. It will be 1. Fine. And then replace small t to be the t minus a. But here it is independent of the t. So for example, say this function will be my t. Then you have to replace by t minus a. So now it will be 1 because my answer is a 1, or 0 whenever t is my greater than of a, because a is my a, otherwise 0. Fine. Now I can apply the shifting first theorem, convolution theorem, fx g of t minus x into dx. So what is that? I can choose any one is the f, any one is the g. So I can choose this is my f, this is my g. Fine. Because I will tell you, and when I choose f is my here, it starts from the a. So I can change this limit from a to t. This is my f is my 1. This will be 2t minus 2x. Now e raised to power 2t is outside. The remaining is e raised to power minus 2x. The integration of e raised to power minus 2x will be here from 0 a to t. So minus half I can take in is outside. E raised to power 2t. I can substitute this value upper limit minus lower limit. So what is the answer of this? Minus half. E raised to power is a 1. E raised to power 2 is common. T minus a is the right answer of this problem. If you choose this is my f and this is my g, then you have to also adjust this t minus a with respect to the t minus x. Then it will be the t minus x will be greater than of the a minus x. So that's why I am choosing this is my f, this is my g. Okay, look at this another one. How you can break them? It's a Laplace inverse of 6 by s and Laplace inverse of s plus 3. Or make sure you can also write this function as 2 over s separate and 3 over s plus 3. That means you have to break 6 as a 2 into 3. Or you can also write this function as 1 over s is separate and 6 over s plus 3 is separate. That's totally on your choice. Whatever you want to take, whether you want to take this or this. So what is the Laplace inverse of this? 6 is outside. Laplace inverse of 1 over s is 1. It is e raised to power minus 3t. Fine. Now I can apply the Laplace convolution result. It is fx g of t minus x into dx. Now again it's on your choice. If you want to take this is my f of t and this is my g, or you can choose this is f and this is g. So again I can solve by the both way for you. If I choose f is my here, e raised to power minus 3t minus plus 3x. So what is the common is 6 is common, e raised to power minus 3. What is the integration of e raised to power 3x? E raised to power 3x over 3 from 0 to t. So 3, 6 will be cancelled out. So twice e raised to power minus 3t, e raised to power 3t minus 1. So if I open this bracket, it will be 1 minus e raised to power minus 3t is the answer. Otherwise, if I choose this is my f and this is my g, then what will be your result is t raised to 0 to t. If I choose this is my f, so e raised to power minus 3x into 6 of dx. Fine. So I can take 6 is common. What is the integration of this? Minus 3x over minus 3. And answer will always be the same, whether you can take this is f or this is g, or this is f or this is g. So I can adjust this is a minus of 2. Fine. And then e raised to power minus of 3t, e raised to power. So I can take minus as a common and it will be same as of this one. And you can see both the answers are same always. So this is the way you can solve this Laplace inverse by using the convolution theorem. So this is the way you can solve it in a very simple manner. I hope you can like, share and comment on my video. Best of luck students. Happy learning.